In this video, we are going to discuss the linked list data structure and the algorithm to insert nodes to it. We will see how to insert nodes at the beginning of the linked list. I will give you a line-by-line simple explanation of all the code that we will be writing in this video. Watch this video till the end, as I will also show you visually how to construct logic while writing linked list algorithms.
My name is Aditya Shenoy from Brainy, where I make programming simple and fun.
YouTube statistics show that some of you who watch my videos are not subscribed to this channel, so if you end up liking this video, please consider subscribing. It is free and you can always change your mind in future. Before constructing the linked list, we need to create a class for the nodes of the linked list. So for that, we will create a class, we will name it as node. Then we will define its constructor by defining the double underscore init function. Apart from the self parameter, it will have a data parameter so that we can set that to the nodes data. So inside this, we will set self.data is data. This data is the data of the nodes of the linked list, and each node will have a next pointer. This is a singly linked list, so we will have self.next is none. And this is all the code that we need to write for the node class. Next, we can define the linked list class. So class linked list. We will again define its constructor by defining the double underscore init function. In this case, it will have only self parameter because we are not passing anything in the constructor, and we will set self.head is none. Head is the pointer to the first node in the linked list. As we are just constructing this linked list in this constructor, there is no node in the linked list currently, and so the self.head will point to a none value. We will also define a function to print the linked list. So we will define the double underscore string function so that we can pass the linked list object inside the print function directly. It will just have a self parameter, and inside this we will define an empty list result, and we will start traversing the linked list from the head node. And while there are nodes in the linked list, we will append the result, the current node's data, and traverse the next node by using node equal to node.next. And finally, we will return a string that will be like this. So all the elements of the list will be joined by using an arrow so that we can visualize the linked list. So this is all the code that we need to write for the linked list. Now we can start writing functions to actually add elements to the linked list. So we will define a function add. First, it will take a self parameter because it is a instance function, and we need to specify the data, like what data should the new node should carry. So inside this, we will create a new node by calling the constructor of the node class that we have created. This constructor takes one parameter, that is the data parameter, and this creates a new node. As this new node will be the first node in the linked list, its next pointer will point to the current head, because after adding this node, the current head will become the second node. So we will have new node dot next is self.head. Like the first node has been added to the linked list, so the self.head should point to this new node now. So we will set self.head is new node. Now we will take an example to understand this and how this function works even for boundary cases as well. So each linked list will have a head pointer. So I will first create this head pointer, and initially the head will point to a none value like this. Now when this first add first function is called, suppose we are adding a data 1 to the linked list. There is no node in the list, so the first line will execute like this: new node is node data. So a new node will be created within data 1. like this. And as per the constructor, by default, the next pointer of the new nodes will point to none values. So we will point this to the none value like this. Now the second line states that new node's next value should point where the self.head is pointing. Like this arrow should point where head is pointing. And there is no change because it is already pointing to none value where the head pointer is pointing. So this second line will not change anything currently. Now the third line, self.head should point to the new node. So we will delete this line and do this. So if we rearrange this connections, this will be the final linked list containing one node and ending with a none, and the head is pointing to the first node. You should always consider operations on empty linked list or single element or just few elements to be the boundary cases of a linked list. So our code is running perfectly for the boundary case as well. Now let's consider the addition of the second node. Again, the first line will construct a new node. So a new node will be constructed. Say the data that is passed is 2. So the new node that is created will be having a value of 2. And again by the constructor, its next pointer will point to none. Now the second line will state that new node.next should point to self.head. This line will make changes to the linked list. So this states that this next line, next pointer, that is this arrow, should point where the self.head is pointing. So this should move over here. I will rearrange this, and the third line states that self.head should point to the new node. So this pointer will shift from this to this, and this will be the final linked list. 2 1 none, and the head pointer is pointing to the first node. So this is working for non-boundary cases as well. So this is a very simple code, just 3-line code, but you need to visualize this connections and changing of connections so that you are able to visualize this code. So to see whether the code is running or not, I will create a linked list object and call the constructor of the linked list class that we have created. This constructor does not take any parameter. First I will print the linked list, empty linked list. Then I will call linked list dot add first and pass 1. Like in the previous example, we have added one node with the value of 1 to the linked list. Then we will again print the linked list to see whether this node has been added correctly or not. Now I will copy these two lines and paste it 2 times to add 2 more nodes to this linked list. Now I will run this, and as you can see there is a blank line over here. The first line states that this is an empty linked list. The second node, that is there is only one node, so that is correctly added. The second node has been added to the beginning, so this is also correct, and node 3 is also added to the beginning of the previous list, that is this was the previous list and 3 is added to the beginning of it, so this is also working correctly. So this 3 line is able to cover all the boundary cases as well as the non-boundary cases. So this is how you write the code for linked list data structure and algorithm to insert nodes at the beginning of the linked list. The time complexity of adding nodes to the beginning is constant, that is O of 1. Inserting nodes at the beginning along with deleting nodes at the beginning will follow the last in first out mechanism, and thus stacks can be constructed by these functions. So by understanding the linked list data structure, you can write code for stacks as well, and stacks are very useful in various applications. If you ended up liking this video, please press that like button, comment any feedback that you have for this video or this channel, share this video with your friends. The code that I write in all my videos of this channel is available in my GitHub profile, whose link is in the description. You can connect to me via LinkedIn, whose link is again in the description. If you want to see a line-by-line explanation of data structures and algorithms like this, check out the playlist over here. If you want to learn Python built-in functions along with various Python features, tips, tricks, and real project examples, then check out the playlist over here. If you want to see a hands-on game development project, check out the playlist over here. And I will see you in the next video.